This is the fourth of a five-part series on functions. Part 1 defines functions and provides some needed vocabulary. Part 2 considers notations used for functions and how to find function values for given inputs. Part 3 looks at algebraic operations of functions, adding, subtracting, multiplying, and dividing. It also suggests instances when the domains of functions need to be adjusted based on those algebraic operations. Part 4 looks at function composition, defining it and looking at composition both for values and for the general case. Part 5 formally defines a function inverse and provides a method for finding the inverse for a function. Examples of all material are worked through in each resource. In the previous resource in this series, we considered the four basic mathematical operations we can do on functions: adding, subtracting, multiplying, and dividing. There is an additional operation we can perform with functions called composition. The basic idea is that we will have more than one function acting on a given input. In fact, we work through those functions in a string. We start at the initial value and work our way outwards. Each function value then becomes the input for the next function. What does the notation for composition look like? There are actually two different notations used for composition. The first is simply function notation extended, where we will see f open parentheses g open parentheses x close parentheses close parentheses. As with regular function notation, we read this as f of g of x. There is another common notation for composition. It looks like f, small circle, g, open parentheses, x, close parentheses. This notation is read as f following g of x. Although the two notations are slightly different and read differently, we work through the problems in the same fashion. Start at x and work outwards. Let's see some examples. Suppose we have the functions f of x equal to 2x plus 1 and g of x equal to x minus 3. We want to find f of g of 7 and g following f of 9. To find f of g of 7, we start by finding g of 7. We plug in the 7 for x, giving us 7 minus 3, which is 4. This function value of 4 becomes the input we plug into function f. So we need to find f of 4, which is 2 multiplied by 4 plus 1. So overall, f of g of 7 equals 9. Now we can find g following f of 9. To begin, we find f of 9. We have 2 multiplied by 9 plus 1. F of 9 equals 19. Now we insert that answer into function g. Finding g of 9 means we have 19 minus 3. G following f of 9 equals 16. We may also want to find a general rule for composition of functions. In other words, we want to find a single function rule that encompasses the entire composition, rather than finding the final answer in steps. For example, suppose we have the same functions from the previous example, f of x equal to 2x plus 1, and g of x equal to x minus 3. We want to find a general rule for the composition f of g of x. We already know that g of x equals x minus 3, since we are told that straight out. So to find the general rule for the composition, we need to take that result, x minus 3, and make it the input for function f. We want to find f of the quantity x minus 3. So we have 2 multiplied by the quantity x minus 3 plus 1. Distributing, we have f of g of x equal to 2x minus 6 plus 1. Simplifying, the general rule for f of g of x will be 2x minus 5. Let's see some more examples. Suppose this time that f of x equals x squared plus 1 and g of x equals 3x plus 2. We want to find g following f of 5, f of g of 5, g of f of x, and f of g of x. The first problem we want to solve is to find g following f of 5. To do so, we first need to find f of 5. We plug in 5 for x, so we have 5 squared plus 1, which is 26. This answer becomes the input for the function g. Now we need to find g of 26. Plugging in, we have 3 multiplied by 26 plus 2. G following f of 5 equals 80. What if we want to find f of g of 7? First, we need to find g of 7. We plug in 7 for x, giving us 3 multiplied by 7 plus 2, which is 23. Next, we plug that 23 into function f. We have 23 squared plus 1. Completing this work, f of g of 7 equals 530. What if we want to find a general rule for g of f of x? We already know that f of x equals x squared plus 1. To find the general rule for the composition, x squared plus 1 becomes the input for function g. We have 3 multiplied by the quantity x squared plus 1 plus 2. Distributing, we have 3x squared plus 3 plus 2. Simplifying, g of f of x equals 3x squared plus 5. What if we compose the functions in the opposite order? To start, we have g of x equal to 3x plus 2. This becomes the input for function f. We have the quantity 3x plus 2 squared plus 1. Squaring the polynomial, we have 9x squared plus 6x plus 6x plus 4 plus 1. Simplifying, we find that f of g of x equals 9x squared plus 12x plus 5.